What if I told you if you could monitor a front door, a garden gate, or even a barn from 13 miles away or 20 kilometers without a Wi-Fi, without a SIM card, and completely free? Sounds futuristic? It is not. It is LoRa. In this video, I'm going to show you how to build a long-range door monitoring system using Heltec N32 module, neatly packed with Meshnology N32 Case and 3000 mAh battery with long-lasting off-grid performance. We're going to use a Hall effect sensor, detect whether the door is open or closed. Perfect for cabins, farm, storage units, or anywhere you need reliable remote monitoring. If that sounds exciting, let's hit the subscribe button if you haven't done it, and let's dive in to build something awesome. This video is part of a 4-video series on Wi-Fi LoRa 32 version 3. In the first video, we learned how to send temperature wirelessly for free over LoRa band up to 13 miles or 20 kilometers. In the second video, we learned how to read up to 150 volts DC and transmit it to 13 miles or up to 20 kilometers for free over LoRa. In the third video, we learned how to turn on and off a relay module remotely over LoRa band at 13 miles or 20 kilometers for free. In the fourth project, we monitor a door using a Hall sensor and LoRa module over 13 miles or 20 kilometers for free. Link to those videos are below this video in the description. This is the Meshnology N32 case, where inside this we have this Heltec WiFi LoRa 32 module and 3000 mAh battery. We have two of this. One is just different color. They are exactly the same thing. And I've done some wiring. Now we are using this one as a transmitter, where I've connected here a Hall sensor. This is a magnetic field sensor or Hall effect sensor, where there is an amplifier and a sensitivity potentiometer where you can set the sensitivity. And here I have just a piece of magnet inside this plastic casing. This is for the door. You can put two screws and attach it. If I bring this here, you will see it has been detected, and now it says that the door is closed because this piece will get closer to here, which I'm going to practically show you. Now the word closed is transmitted, and this is the receiver, this is receiving it. If I remove this or the door is opened, it shows open and the word open appears. And here we can connect a buzzer, which I'm going to show you the circuit inside. There is a transistor and a resistor, and you can use also a relay module. Now if I connect the relay module, these three wires are connected to 3.3 volts, to ground, and to pin 4 of this microcontroller, which is inside the case, which I'm going to show you inside this. Now, right now, as you can see, the door says the door is closed because the door is closer. Now if I remove this, it says open and the relay is turned on. Relay is just a switch. This is an electromagnetic switch where it will close and open a switch, so you can connect your AC, DC load, whatever you have. You can turn it on and off when the door is open or closed. Now it says open, and then you see closed. And if I remove it again, the relay is turned on. Now I've connected the buzzer instead of relay at the same pins. And let's remove this. The light is on. It sends open, and the buzzer is now buzzing. Now this was how our project works, and I'm going to show you all the wiring and code and practically show it on the door. And then we are going to use two of these to transmit data and then we are going to use it on the field to send data. I've connected extra wire for the transmitter so I can disconnect it and we'll turn it off. For the receiver, this will consume very little energy, and with this battery it lasts more than 2 or 3 days if you charge it fully, at least 2 days. So I remove that, and you can use high gain antenna where this will transmit better, which means longer distance, and if you use the same antenna on the receiver, it will increase the sensitivity of the reception so you can receive better signal. Meshnology, when you come to meshnology.com, I've reviewed for this N30, but in this video we're going to do the review of this N32 series. You can buy it with a battery, with an antenna, with all these packages. You can purchase it from Meshnology.com or from Amazon. The links will be provided. You can buy a package with a microcontroller and LoRa and 3000 mAh battery, extra antenna, and the shell. You can get the red one, 2 package, 1 package, whichever package you prefer. You can purchase the package green, red from Amazon, or with a battery. Any package you want, 1 or 2 packages, are all available. The links will be in the description below this video. Let's have a look at the case. And this is the package of 2 batteries I purchased. This is a package from Amazon. It comes with a charger, and each battery is 3000 mAh. 1 cell. This is 3.7 volts and 11.11 watt hour. The module first connect the cable that comes with the module, and if I turn it around you see it. Then we will remove the nut, connector here. This is inserted fully and you have that much room out. Attach this piece of ring. Let's see how much room we have. Yeah, so insert the spring washer. Round and squared holes, the same as these two, so round will go with the round. use these two screws to attach them at these corners. Connect the antenna, because without the antenna, do not connect the battery. Our receiver is now packed and ready. Let's test the cable connector to see if it charges. Now there is a problem. If you want to disconnect the battery, the power is already on. You cannot do that. It might damage the transmitter. So what you do is open everything, disconnect the battery, and then remove the antenna. Otherwise, the LoRa module might get damaged. And here is the wiring for the Hall sensor. We have a magnet, and this is the Hall sensor module. Digital out is connected to pin 4, plus is connected to 3.3 volts. G or ground is connected to ground. The last pin, analog out, is not connected. And this is just one cell battery, so this is a full wiring for the transmitter. If for some reason you want to use a 5 volts relay, then we need to have a boost converter where it will get 3.3 volts, and you adjust it using this screw to 5 volts, and the 5 volts will come to the middle pin of relay. Ground is connected to the ground, so this is input and that's output, and pin 7 or pin 4 is connected here, depending on how you set it in the code. And these two terminals are for your load, so the power will come from AC or DC. One wire comes here and exits, goes back to the bulb, for example, and the other wire comes to the bulb, and when the door opens, this relay will turn on and it will turn on this bulb. So you can connect it to powerful alarm or some kind of gate closer or something. Here is the wiring for the buzzer. This is our board. I place here a breadboard so we can see it clearly. This is the 2N3222 NPN transistor. This is the face up with a marking. From the right pin, we are connecting a wire to the buzzer, to the negative of the buzzer. The positive of the buzzer is connected to 3.3 volts, which is the second pin of microcontroller. Now, the left pin of this transistor is connected via this wire to the ground. The middle pin, which is base, it has been connected from pin 4 via this 1 kilo ohm resistor. This is not critical, 1 kilo ohm, 5 kilo ohm, 10 kilo ohm. It's just a switch. It is connected to the base. So the buzzer will be ready. I started using a 2N3222 transistor connected the black wire on the emitter, which is a left pin, and then on the middle pin I've connected a 1 kilo ohm resistor. I have soldered it, and the other side of resistor is connected to this purple wire. The right pin is collector, it is not connected to anything. Then, as you can see here, I have the buzzer is such that the left pin is positive, the right pin is negative. I have soldered the right pin or negative pin of the buzzer to the transistor. That's a collector. And I have inserted heat shrink sleeves to prevent it from short circuit. And now we have only left pin of the buzzer left, which I've connected to the red wire, which goes to 3.3 volts. This buzzer is actually 5 volts. I've tested it and it works also with 3.3 volts. So this will work for any other project that you have. This is a complete project. I put also another heat shrink here, so it's protecting all the components and also holding it tight. So this goes to 3.3 volts. This is ground, and this goes to the resistor or to our program to pin GPIO 4. And here is my voltage source from these two. 3.3 volts is 3.3 volts. Black is ground. And if I connect this pin to the 3.3 volt, it should make buzz. So the transistor is working and the circuit is ready to be tested. Let's create some hole here for the wires. I'm going to connect these 3 wires. This will go to 3.3 volts ground, and this will go to pin 4, and they will exit like this. Now I've placed it, and I'm going to close it down. We need to do some adjustment in order for the door sensor to work. These are the 3 wires that have been connected. This is 3.3 volts. This black is ground, as I've shown you on the wiring, and this is connected to pin 4. Now right now the door is open because this is far away, but when the door is closed, this should be here. Now, if you do not adjust this, this will not react. Let me remove this and look at this here. I'm rotating it clockwise. I hear now click. So this is very simple. Rotate it clockwise until it clicks. Let me put the microphone. So for this type of strong magnet, this is fine. You see, it can work even up to this distance, but you can change the sensitivity so it can get sensitive even with far distance. So let me go back. So right now, I'm putting it here and this much distance. Okay. Counterclockwise. Now, this is so sensitive, even from this distance, it assumes that the door is closed. So if you want to make it very sensitive, as you can see, just change this and it will work up to this distance. But I prefer this to work from this distance. Now I have to rotate this clockwise. So I want this to be only at a close distance. So when you go here, it should be on. The door should be shown as open. Even this one, I want to set it to show open, which means the light should be on. So rotating it clockwise. Still not, it's still going up and down. Now this is working with very close distance. As soon as you go a little further, it will trigger. In order to work with Heltec WiFi LoRa 32 board, you need to install certain software on your Arduino IDE. First, we need to install the ESP32 boards, which is needed for any ESP32 board. Open your Arduino IDE. You can get it from arduino.cc. This is a free software. Go click here, boards, and then type ESP32. Here it says ESP32 by Espressif, and you will see here install button like that. Click on the install and that will be done. Then we need to install certain software for Heltec. First, we will install ESP32 package. I will provide you this URL here, the JSON URL, which you can get it from Heltec documentation page under the ESP32 series. You right click and copy it. I will provide you the link. On Arduino IDE, click File, Preferences. This area is for additional boards. Click to open it so we can see there is nothing. If you see another line, just at the end of the line, click and go down, and then right click and paste. And click OK, and click OK. Wait for this to complete. Click on boards. and type Heltec ESP32. You will see it here, and this button would be install. Click on it to install it. Then we need to install ESP32 extended library from Heltec. Now click on library. This was board and this is library. Click on it and type Heltec ESP32. And you will see here it says Heltec ESP32 dev boards. You see it says remove. If you have not installed it, you will see install button. Click and install it. Then we need Adafruit GFX library for the display. Come here, click on library and type Adafruit GFX library, and here the first one, Adafruit GFX library. Click install. It says it needs dependencies. Click install all. Wait for this to complete. Then we need to install the Robojax Heltec LoRa 32 zip library. This is needed for OLED and reading voltage. I will provide you the link from the description. Download and save that .zip file in your computer somewhere. Then click on Sketch, include library, add .zip library. Browse to where you saved it, find it, click select, and then click open. All the libraries and files that were needed have been installed. To check if the Robojax Heltec library have been installed, click on File, Example, scroll down until you see Robojax Heltec LoRa 32, and these files are there. Make sure the board is selected. If not, click here and select board and type here V3. You will see Heltec LoRa WiFi LoRa 32 V3. You see another kit is there. This says without LoRa, so select that, and then you should see the port. Select and click OK. Now let's open the transmitter code. Click on File, Examples. Under Robojax Heltec LoRa 32, select Door TX. This debug is to this line. If you set the debug to true, when you open the serial monitor, when the device is connected, it will print you a lot of information. This is a pin that is connected to the door Hall sensor switch, pin number 4. If you want to change it, you can do so. Do not change these. These are the texts that are displayed on the transmitter and receivers. These texts, 1, 2, 3. Change them accordingly, but keep in mind that double quotation must exist because these are string. And this is your secure key. It's your secret, otherwise everybody else will receive your signal and the alarm will be triggered with false signal. This is a value for the frequency of your LoRa module depending on a region. Set that accordingly and it must match with the transmitter and receiver. And this is the most important part, which is the TX power. In the lab I set it to 2, but you can use it between 2 to 20. Suggestion is it should go up to 14, but you can go even up to 21 dB milli, which is the maximum power. But when I do the range distance test, I will set this to 20. There is no other setting here needed. When everything is ready, just click to upload your code. Now let's open the receiver code. Click on File, Examples. Scroll down to Robojax Heltec LoRa 32 and click Door and click on Door Alarm RX. This is the same as before for debugging, and this is the pin that is connected to control the relay. These are the text if you want to change. This is the value when the relay is triggered. You want to keep it running. For example, if the door opens and you want the alarm to run for at least as long as you want, so change that. For example, make it 10,000, 20,000, whatever you want. You can do that. Right now it is set to 1. And this is your secret key. This must match with the transmitter. This also must match with the frequency of your region and frequency of the transmitter. Do not worry about the transmission because we are not turning on the transmission section, and that's it. There is no issue. The code will be uploaded successfully, and it says done uploading. Now here is a demonstration. In the code, I have set the transmitter power to 2 dB milli, which is the lowest because we don't need much power. And as you increase the power, the transmission time with the battery will be decreased. For example, if you set it at 2 dB milli for a shorter distance of few meters, for example, or few yards, this might last 1 day or 2 days or even longer. But if you go with 20 dB milli, it might work for, I don't know, 12 hours, 15 hours. I have not tested it fully, but it will last very long still. So I have set it with 2 dB milli, and now at the moment the door is closed, and here it works fine. It says closed and the buzzer is off, and if I remove this, it detects it and it sends a signal. It will turn it off. And if the door is closed back, it's closed. Now let's go and test it on the actual door. Here I have attached the double-sided tape, and I'm attaching a tape here. When I remove it, I can attach this anywhere I want. And here is my setup. I've attached this magnet. You can put any magnet that you want. And this is the Hall sensor connected. This is Meshnology N32 with, now the door says close, and also I'm recording it on the other side. Let's open the door. So it says open, and also the alarm is on. The door is closed and the alarm is off. We tested the project in the lab, and I showed you that when you open the door, it sends the signal that the door is open, and when you close it, it will send another signal that the door is closed. Now you would be wondering how this will work over 13 miles. Well, I have tested the same exact Wi-Fi LoRa 32 version 3 with N32 module and 3000 mAh battery from Meshnology. In that setup, we sent the voltage. The setup specification, everything is the same. Instead of sending a on and off signal, we sent the voltage for the battery. So the setup and specification is the same, and you see the real feeling of how this transmission and reception of signal will work. Now to get started with the range test, I'm setting this power to 20. When I work here in the lab, it will be 2 because we don't need, that's the lowest. And I can go 21, but I'm going with 20 to test it. For the transmitter code, you must select your security key, which must matches with your receiver. You use the same code, you can change it, and this is the frequency that we set. So these two must match, and then set the power that you want. Here, the test is performed in this area on the lake because there is no obstacle on the path and it's direct line of sight. We place our transmitter here, and it's almost about 10 meters above the water level. And as you can see, there is no obstacle on the path because we avoided all this, and it's about 13.04 mile or 20.98 kilometers, which is almost 21 kilometers. Let me show you my setup for range test. I've placed here a camera, transmitter is installed on a tripod, and it's connected via these wires down to the battery where we can reach up to 30 volts of the voltage. I've set this up by the lake, and we are transmitting it about 5 to 10 miles or even more. I'm going to see how far this can transmit. We're going to transmit the signal on the other side, and we're going to see the voltage that's being transmitted, receiving it on this receiver, and I'm going to show you on the Google map to see how far we are. I've left the transmitter there and then walking towards my car to drive to the further destination so we can receive the signal. I'm 13 miles, which is about 20 kilometers away from the transmitter. Here my map is showing it. I hope you can see it because it's a bright sun, and the voltage is now on the screen. So I've called already my friend on the other side. So I'm gonna ask my friend to change the voltage. Please change the voltage.
Okay.
Okay, so as you can see now, we see about 9.71 volt and 13 miles. Amazing. This is unbelievable. So we are 20 kilometers away from that direction where the antenna is pointing, and we are receiving signal. So for conclusion, I would say if you want off-grid communication, sending and receiving information, monitoring devices or something, Wi-Fi LoRa 32 is the best option, very cheap. The link to purchase any of these components are below the video in the description. I have a resources page with all the photo, wiring diagram, everything, and the link will be below this video. If you purchase any product from those links, I'll get some commission. It will help me as well. Thank you.